Alright guys, so today we're looking at 9.5, which is the last lesson of Unit 9, and we're going to be looking at what we call causation versus correlation. Tong said he's heard those words before. Anybody else heard those words before? Either causation or correlation, one of the two? Causation means that if I say something causes another, can anybody kind of explain to me what they think that might mean? Let me see. What if I say candy causes you to get cavities? True or false? Jonathan says no. It depends, right? If let's say Tong eats a ton of candy and B eats the exact same amount of candy. If Tong gets a cavity but B doesn't, does that necessarily mean that eating the candy caused a cavity? No, but it does have what we call a correlation. Okay, correlation means that typically they go together. So, for example, the kids that eat more candy tend to have more cavities, but it doesn't necessarily cause it. Okay, so here, there's the definition for you. First definition is causation. Causation is when one event causes a second event. So, all of the rain that we had over the weekend caused some flooding or mudslides. True or false? True. The rain is why we had the flooding and the mudslides. Okay, so that would be something that causes something else. In causation, we have two things, a necessary condition and a sufficient condition. Okay. A necessary condition, a correlation is a necessary condition for causation. So they have to be correlated, they have to go together in order for one to cause the other. And that's exactly what this says. For one variable cause another, they must be correlated. Necessary means it has to happen. A sufficient condition means that it's enough to cause something. So a correlation is not a sufficient condition for causation. So just because two variables are correlated, it doesn't mean that one necessarily causes the other. Okay? So that's necessary and sufficient. So example 1, I want you to write down, and let's go piece by piece. Many medical studies have tried to prove that smoking causes lung cancer. Okay, so all of our questions are going to be about smoking and lung cancer right now. Here's what I want you to write. Part A. Is smoking a necessary condition for lung cancer? Okay, so write that down because I do want you to have the questions and your answers written down. So that way for your homework and other questions you have a reference. Okay guys, so let's think about it. Is smoking a necessary condition for lung cancer? Do you have to be a smoker in order to get lung cancer? No, right? You can get lung cancer regardless of smoking. So is smoking a necessary condition? No. So we're going to say no, and then I do want you to write an explanation. So you can, let's say people can get lung cancer without ever smoking. Okay, so people can get lung cancer without ever smoking. It is possible. So then my next question is smoking a sufficient condition for lung cancer? Okay, so guys, let's think about this. Is smoking a sufficient condition for lung cancer? Is it enough to say that if you smoke, you will get lung cancer? Every single person, every single smoker gets lung cancer. So is it a sufficient condition? No. So this is no, because not all smokers get lung cancer. Okay, so a necessary condition means that in order for the end result to happen, you have to have had the previous. So part A was necessary. So in order to get lung cancer, you had to be a smoker, which we knew was not true. Sufficient condition is that if the first one happens, then you know for sure that the second one will happen. So if you're a smoker, you will for sure get lung cancer. We know that's not true either. But let's look at this question. Is there a correlation between people who smoke and people who get lung cancer? Yes, right? So those people that smoke have a higher risk of getting lung cancer than non-smokers. So I would say yes, people who smoke are, what would we say, have higher incidence, meaning it happens more often, of getting lung cancer than non-smokers. Okay, so there is definitely a correlation. Okay, guys, so my last question to you then, is it true that smoking causes lung cancer? So guys, based on what you know about lung cancer and smoking, is it true that smoking does cause lung cancer? It causes it, but does every single person who smokes get lung cancer? And does every single person that has lung cancer, are they necessarily a smoker? No, but scientists have proven that smoking damages your lungs, and that's how that causes you to get lung cancer. So if you have damaged lungs and therefore lung cancer, you're not necessarily a smoker, but smoking does cause damage to your lungs. So yes, smoking does cause lung cancer. It's just not the only cause of lung cancer. Does that make sense? So we would say that yes, scientists have proven that smoking damages the lungs and causes cancer. Okay. Okay, so let's go back to our definitions really quick. In order for something to have causation, so in order for smoking to cause lung cancer, a correlation was necessary. Is there a correlation between smoking and lung cancer? Did we determine that there was a correlation? Yes, so we have correlation was a necessary condition for causation, and we did determine that because they had a correlation, smoking can cause lung cancer. Correlation is not sufficient, so that's saying that just because there's a correlation, that does not necessarily mean that one causes the other, but they have to have a correlation in order to have causation. Okay, so there has to be a correlation, but it doesn't necessarily mean that there is a correlation. But science has shown that smoking does cause lung cancer. Okay, so that's our lung cancer, looking at each of those. Now what we're going to do is I'm going to give you two statements, and all I want you to determine, so I'll give you guys a chance to write them down and think and talk about them with your group. All I want you to do is determine if the correlation implies that one causes the other. Okay, so here are your two statements. The number of cavities in the teeth of elementary school children is highly negatively correlated to the student's reading vocabulary. Negatively correlated has to do with the graph. So if I was to graph this and put vocabulary on the x-axis and number of cavities on the y-axis, oh, I have them backwards. It would be vocabulary and cavities. Okay, so the negatively correlated part means that it has to do with the graph. So as a number of your cavities increases, the vocabulary in elementary students decrease. That's what negative correlation means. So it means that if I have less cavities, my vocabulary is higher, and as I get more cavities, my vocabulary in elementary students starts to decrease. So it's negatively correlated. Okay, so that's all that the negative positive means. It means that on your graph, it either has a negative slope or a positive slope. Okay, so that's your first statement. The number of cavities is negatively correlated to students' reading vocabulary. So the negative part does not mean that they're not correlated. It means that as cavities increase, vocab decreases. Okay. Now, the next example is there is a positive correlation between the hours of exercise and the levels of fitness. So if I were to graph hours of exercise, the hours of exercise on the X and the level of fitness, so fitness level on the Y, if I'm telling you they have a positive correlation, that means that as I increase my hours of exercise, what's happening to your fitness level? It's also increasing. So positive correlation means that both are increasing as each other one increases. Negative correlation means as one increases, the other decreases. Positive correlation is not necessarily better than negative correlation. They both still have a correlation. It's just telling you, the positive and negative is just telling you which direction the data is going. Okay? Homework. Okay, so what this is saying is as the number of cavities that you have increases, typically elementary school children have a lower vocabulary. That might be because they're at the dentist so often, missing school because they have to go get their cavities filled. I don't know. But there is a negative correlation, meaning as cavities increase, vocabulary decreases, but they are correlated. But do the cavities cause children to have lower vocabulary? No, that shouldn't like make no sense at all, right? So I would say no, causation is not implied. Okay, so there is a correlation, but it should be pretty apparent that having cavities does not cause you to have a low vocabulary. Okay. What about number 3? Number 3 says there's a positive correlation between hours of exercise and level of fitness. So the more you exercise, the more fit you are. Does that imply causation? Yeah, it should. That's why you take PE class, right? So yes, causation is implied. Okay. Now, I don't want you guys to think that all positive correlations imply causation and all negative correlations imply not causation, because that's not the case. That's just for these examples. You have to look at each specific instance individually, okay? So the positive and negative correlation just has to do with what the graph would look like if we were to plot the data, okay? That's it, guys.